So we're going to talk about how you go about balancing a redox equation. So because we have the exchange of electrons, we cannot balance this in the traditional way. We have to balance it using a special method. Now, for us, a redox problem is always going to be identified. It's not going to, it would mention in the problem to balance this using the redox method. That's the method we're about to discuss. So the thing with balancing redox is it takes a little while because there's a lot of steps. So you might notice that there's a lot of space, and that's really the reason why. So we've already been practicing the first step, which is assigning oxidation numbers and then determine which species is being oxidized and which is being reduced. So we have to do that. That's the first step. I have an example here. We have the iodine ion here. Because it's the ion, I know that because it has the -1 charge. It has a -1 charge. Then I have iodine, the element. I know that because of the 2 here, it's a diatomic. And then the chloride ion, which is -1. The other thing I need to determine are the oxidation numbers in the ClO3 -1, which is chlorate. So I'm going to identify oxygen first. Oxygen is -2. I have 3 of them, making it -6. So the chlorine is a +5. So I'm going to do the exact same thing I did before. I'm going to connect them. So iodine is going from -1 to 0. So that is losing electrons, which is LEO, which is oxidizing. Then the chlorine is going from +5 to -1. This is the chlorine here is being reduced. That's the first step. The second step is writing out the half reactions. We're going to split this reaction up into 2 separate reactions. So we're going to take the substance that has chlorine. We already kind of connected it together. So let's start with that one. I'll do this one in red. So we're going to take ClO3 -1 to Cl -1. So I'm pulling out what I identified above, whatever substances I had. So we're just going to identify the one being reduced first. It doesn't matter which one you do first. I just picked the one that was reduced first because that was the first one there. So we're going to balance all atoms other than oxygen and hydrogen. So oxygen and hydrogen have a special process. So we are going to treat those differently. So we have 1 chlorine on either side. So we have completed the first step. The second step is balancing oxygen. I'm going to balance oxygen by adding water to one of the sides. So I see on the reactant side I have 3 oxygen. So on the product side I'm going to add 3 waters. That may seem kind of odd, but if you think about this reaction, we have ions. This is taking place in water. So if we produce a little bit of water or use up a little bit of water in the reaction, because there's going to be so much with the water, so much water that is dissolved, and it's not going to make much of a difference for us. So that's why we use the water. So then this third step is to balance the hydrogen by adding hydrogen ions. So we have 6 hydrogens on the product side, so I need to add 6 hydrogen ions, or H+1s, to the reactant side. The last step, we want to make sure that all charges are balanced, which we're going to balance by the electrons. So right now, we want to look at the overall charges. So on the reactant side, I have a +6 from the hydrogen. I have 6 +1s and a -1. Together, that's going to be +5. On the product side, I have a -1. Right now my charge isn't balanced. But what I can do is I can add electrons. What I'm going to do is I'm going to add 6 electrons to the reactant side. Why 6? If I add 6, that goes from positive 5 to negative 1. Both sides have to match. They don't have to be 0, they just have to be the same. So we've completed one of the 2 half reactions. We're going to now work on the other one. We're going to do exactly the same thing. So we have iodine ion becoming the iodine element in its elemental state. First step, we want to make sure everything but oxygen and hydrogen is balanced. In order to do that in this one, we need to put a 2 in front of our ion. So we have 2 iodine ions and 2 iodines that are the diatomics. We have no oxygen and no hydrogen, so we don't have to worry about that. So now we have to balance our charges. So right now I have a -2 on the reactant side and a 0 on the product side. So the last step here is adding 2 electrons to the product side. So that one was a little bit easier. We didn't have to worry about oxygens and hydrogens. Those make it a little bit harder when we have those. So now we need to balance our electrons. This is the key. We have to lose as many electrons on the reactant side as we gain on the product side. So we have 6 on the reactant side, 2 on the product side. So in order to balance the charge, we're going to have to multiply the iodine equation, which is the equation being oxidized, by 3. So we're going to take everything in there and multiply it by 3. So we're going to have 6 iodine ions and 3 iodine elements plus 6 electrons. So I'm actually going to rewrite that below because the last step is adding the 2 equations back together. When you're at this moment, you can cancel things out. In this your electrons have to cancel. That was our goal of the last step of the equation. Electrons are canceling out. They have to cancel. But let's say if you had waters on both sides or hydrogen ions, all of those things you can cancel out. You can cancel out whatever is the same on both sides. And then you're going to combine it. So you'll have 6H plus ClO3 minus 1 plus 6I minus goes to Cl minus 1 plus 3H2O plus 3 iodines. That is my finished product. Like I said, these problems are a little bit long. They have many steps, but you do the same steps kind of over and over again. It's not like you're changing them up. So we're going to look at another example here. This one's a little bit different. So we're going to do the exact same process. Manganese is +2 because it's an ion. Bismuth's +3. Again, it's the ion. So we have 2 substances with oxygen. So oxygen is going to be -2 in both of those. So this is this BiO3. The bismuth is going to end up being +5 because we want to make sure we keep it to the -1. And this is permanganate. We're going to have -8 from the oxygen, so manganese is +7. +7 for manganese is not uncommon. It is one of the possible oxidation states. So we're going to link those similar things together. We're going from +2 to +7, so we're losing electrons, which is oxidation. The bismuth is going from +5 to +3, so we're gaining electrons, which is reduction. Whenever I do these, now I do it in my head, but I always think Leo, losing electrons, is oxidation, to figure out which one that is, and then Ger, gaining electrons, is reduction. I say those silly phrases in my head. If you want to say them aloud to help you with these, you can. Okay. So we're going to split it up. So I'm going to have Mn plus 2 going to MnO4 minus 1. Everything but O's and H's are balanced. That's the first step, which they are. Mn is balanced on both sides. Then I'm going to balance the oxygens using water. So I'm going to add 4 waters to the reactant side. That balances my oxygen. Then I'm going to add 8 hydrogens to the product side. Now my hydrogens are balanced. We're going to take a look at my charge now. So water has a charge of 0. Manganese is plus 2, so this whole side is plus 2. Manganese is minus 1. Hydrogens, here I have 8 of them, so we have a positive 8 charge. Minus 1 plus 8 is going to be plus 7. In order to have the same charge on both sides, I'm going to add 5 electrons to the product side here. So those 5 electrons give me the same charge on both sides. Okay, that's half, so we're halfway done. We're going to do the same thing with the other part of the equation. So I'm just pulling out the things with bismuth in it. Bismuth is balanced on both sides, so I can move on to oxygen. I'm going to have to scroll over a little bit. So I'm going to add 3 waters to the product side. Now that oxygen is balanced, I'm going to add 6 hydrogens to the reactant side. And now I'm going to take a look at charges. So I have plus 6 and minus 1, which gives me overall plus 5, plus 3 and